So today we're looking at section 4.6. It's very similar in nature, okay? But it's called regression when you use a, I guess, a tool to help you find the line. So when you do it by hand, it's called a line of best fit. When you use a calculator or a computer, it's called regression. So a regression line. So essentially what we're going to do today is we're going to kind of mirror what we were looking at yesterday, but we're going to use the aid of Desmos to help us do it. Does that make sense? All right. So we'll get into a couple different ideas, but we're going to check our first one from yesterday, the ice cream sales versus the temperature. So if you are on this screen in the top left corner where the plus button is, if you click on that, the third option down should be a table. So using our information from yesterday, would you please input in the table those values? So like the temperature, yep. So I think there's 10 total. Nope, there's 12 total. Okay, so put the temperatures in and then put the ice cream sales in. You do not have to put the degrees or the money. Nope. It's probably easier if you just go straight down the line. Put in all those X values first. Bless you. Yeah. Now, as you start to enter these, obviously they're not going to show up on your screen because the values are outside of our window range. So you can do one of two things. You can zoom out until you find them. Or if you notice on the left-hand side of your screen in that blue bar where our table is, down in the bottom left corner of that blue bar, there's going to be a little magnifying glass with a plus inside of it. If you click on that little magnifying glass, it will zoom in to where your values are located. Click on that little magnifying glass. You see it down there?
The zoom fit?
Yes, the zoom fit. It should look very similar to what we graphed yesterday by hand. Okay, so if you click on that little magnifying glass down there, you should get your values. Now that's really close to what we had yesterday. We just have one more thing that we need. What's the one thing we're missing? The line, right? Yesterday, what's up? Then chances are you better go back through and look at these values and make sure you don't have one that's mistyped. Did you click on the little magnifying glass that was down in the bottom corner? Yes? No? Oh, okay, so click on it. Did you click on it? What in the world? Just click in there somewhere. That little magnifying glass right there. Okay, yesterday, this is where we all differed because we chose what we thought was the best line. Dude, how many of you have an equation on the bottom of your paper from yesterday? Yeah, you have a y equal statement, you have a slope, you have a y-intercept, right? Okay, so we're going to have the linear regression model created for us by the Desmos calculator. Okay, do you remember what a general equation of a linear line looks like? This should not be a difficult statement. It looks like y equals what? Mx plus b, okay? So in a linear regression, we're going to use the basis of that equation. So we're going to use y equals mx plus b, but we have to change it just a little bit. Okay. Number one, please notice that in the equation, or excuse me, in the table here listed, these x and y columns are called x1 and y1. So in this linear regression model, I'm going to mirror that. Meaning instead of saying y equals, I'm actually going to say y1 equals. Because these values here are listed as y1. If you had a second table in here, they would say x2 and y2. So when you type this, you wouldn't say y1, you would say y2. Right, does that make sense? Okay. And then our x's over here have an x1. So in this equation, we'll put that as a 1 as well. So we're just basically telling the calculator, listen, you're going to get your x and y values from the table that's labeled as x1 and y1. So whatever they said, we would mirror them in there. All right. And the only other thing we have to change is we're not going to use an equal sign. We're going to use the symbol that looks like that. And it's called a tilde or a twiddle, I think. I've heard a tilde or what? A twiddle, I think. It's located in the top left corner of your keyboard above the, or actually right below the escape button. Do you all see it? A squiggle. All right. So in the next open blank down here, if you just click below the table we were just in, so you're in number 2 down there, we're going to mirror that statement that we see on the board. So we're going to type in y and then the number 1, and you're going to see that subscript of 1 pop up on your screen. And then we're going to use that tilde button, which is right below the escape. So shift and the apostrophe, and we're going to see that tilde pop up. And then we're going to type in m and then x1 plus e. And you should see a line come up on your screen. Did I lose you? So basically you want it to look like what you see on the board. Do you have that? What do you have? You said no. So right here. So hit shift. Nope. Shift. So hold shift down. Hit it. So now we have, so then m and then x1 plus b. There you go. All right. So you get a couple pieces of information here. Number 1, you should now see a slope and a y-intercept. Do you see them in your little box of parameters down there? Okay. So what this is telling us is the linear regression line, or essentially what's really the best line for this information, would have a slope of 30.0879. So look at that in comparison to yours, and what you had originally done on your graph paper. Is it close? It doesn't. So then that means over here we got something that's not right. So if we go through those, one of them's off. So that one right there, look, was 215. You put 214.
That one also, that's supposed to be a 4.
There you go. So on what? Well, this was yours, right?
Yeah.
And what we're seeing now is this slope right here and that y-intercept are in fact actually the best to mirror this information.
So mine's not like that close.
Yeah, we're just trying to see how close we were when we did it by hand. Nobody's is going to be right. Don't worry.
Is that pretty close?
It's not too far off.
I don't understand the thing on there.
So it's y1 and then shift and then okay, and then m x1, because these columns were labeled x1 and y1, and then plus shift plus b. Now your graph will look a lot better if you click this little magnifying glass. So, all right. Okay. So the best slope and y-intercept would be the 30.0879 and a y-intercept of negative 159.474. Okay? So here's what I want you to do.
What if you're way off and you have no clue what you did?
Well, you're way off on this.
I have y equals 64.33x minus 698.5.
Here,
Yeah.
not here.
Yeah.
Oh, okay. So, yeah. All right. So when the one that's on your paper, right? That was what you chose yesterday, where you thought the line should be. So all I'm trying to get you to realize is, sometimes when we do this by hand, by ourselves, we don't end up with what is actually what we should have. All right. This one here, does everybody have this information on their screen? Is there anybody that was not able to get that? Okay. So this here, I just wanted you to compare your work to this. Now, if you had a slope that was close to 30, like +2 or -2, meaning anywhere from like 32 to 28, was anybody in that range? Just your slope on your paper originally. You had 30.6? Holy smokes. So that's like really close, right? Okay. Oh, okay. So, so all that means is you did a really nice job of reflecting what you saw in those points. It means your line was really, really close to being accurate. Okay. I can use this equation though to then generate predictions about anything that I would want. And we can do this in one of two ways. If I know this information, I could say, well, what if it's going to be 25 degrees Celsius? I simply, in place of this x, replace it with a 25, and I could find that result. Or over here on my graph, if you bring your cursor over to the line and you drag along this line, you'll see ordered pairs that are being created. So I said 25 degrees Celsius. So if I bring this down here to 25, it says I should make 590. Where did it just go? Yeah, it is. It's like $593, give or take. Okay. So I can do it on the line or I can use the equation to make that happen. All right. So that's one of the two things that we're going to practice today. Here's the other thing. In this box of the regression model, we have another piece of information that's going to be important to us, and it's labeled as the value of R. Do you all see that in your statistics? It is what's known as the correlation coefficient. All right. And here's what it does, that value of R. This correlation coefficient basically is on a scale somewhere between the values of -1 and +1. If your value of R happens to be 0, what that's telling you is that your information has absolutely no correlation in it whatsoever. The things that you tried to compare don't belong together. Your grade in history and your shoe size. Those don't correlate to each other. Sorry, Aiden. Okay. The closer you get to 1 or to -1, the more closely they're related to each other. If you get all the way to a +1, what that says is your dots form a linear graph with a positive slope, meaning all your dots form a straight line. They're 100% of the way to being a straight line. Does that statement make sense to you? If your value gets all the way to 1, you've got a perfectly straight line in a positive direction, okay, going uphill. If your R value gets all the way to -1, then you also have a linear line or a linear graph, but now it has a negative slope. You with me on that one? So it's 100% of the way to being a straight line. It's just in a negative direction instead of a positive direction. So for us, in this one here, our R value was 0.9375. So that's like way out here. So it's like you could think of it as like being 94% of the way there. So when we make predictions, will they be accurate if they're 94% of the way to being a straight line? If you got a 94% on your test, would you consider your results to be accurate? Like, do you know what you're doing? If you got a 94 on your test, I would say yes, right? If this R value came out to be like 0.53, that means you're like halfway there. Would you consider those results to be accurate? Do you know what you're doing if you got a 53% on your test? No. He's like, maybe. No. All right. So in that situation, the closer this R value gets to 0, the less accurate it is. The closer it gets to 1 or to -1, that just simply means whether it's going uphill or downhill. Okay. So the closer you get to 1 or -1, the more accurate your information will be. Are you with me on this idea? Sort of, kind of? We're going to try it with another one, okay? So over here, let's use the following. So we're going to come over here and let's try this one here. Okay. So here we have the top 10 scores from Wednesday's bowling league. All right. We should go bowling. I like to bowl. Yeah. All right. So what I want you to do in your Desmos is go back to your table and just clear it out. Just click X and close it. Okay. Do the same thing with your regression. Just close all that. And we are going to put in these scores. So our X values will be 1 through 10. And our Y values will be, well, first place got 210, second place got 197, so on and so forth. Correct. So it's in 2 columns. Or, yeah. In bowling? No, you want the highest. Yeah. This isn't golf. Golf, you want the lowest score. Huh. Okay. So go ahead and put in 1 through 10 in your X column, and then in your Y column, start putting in those scores. What's that? Yeah, it does right on the top, doesn't it? It says vote. Right. Okay. Now remember, after you type your values in, use that little zoom fit magnifying glass down in the bottom left corner there. Click on it so you can see what your picture looks like. Well, in order to get the line, you have to use the linear regression. So you're going to write Y1. That little symbol, the little what appears to be like a squiggly line, means by definition, how Desmos views this, they would say that this is going to be regressed against. So meaning we're going to compare those Y values to those X values. And we're going to see if they fit a linear graph is what we're trying to find out. Okay. How many of you at least have those 10 values typed in? So I can switch my, okay. So if we switch our screen back over here, then remember, if your zoom is off in any way, you should be able to see that little magnifying glass there. If you click on it, it should kind of center your stuff back up. What's up? Okay, so remember though, you wanna create a second equation down here. Okay, what did you type in? Okay, so y1, yeah, mx1 plus b. Oh, it shouldn't matter. It did not.
Oh, never mind.
You know what you
There it
did?
is. I didn't put the X.
Okay. All right. So do realize, though, that if for some reason your title of your table was not X1 and Y1, then you could not use those down here. Does anybody's table have something other than ones in the top? Okay. So whatever those are, they have to be in here as well. Absolutely. You can make whatever you wanted. I would not be in your best interest, but you could. Okay. Yes. Yes. If you make a second table right now, the second one will say X2 and Y2. If you made a third one inside of this same window over here, if you added a second one. Okay. So what is your slope of this one? We should have a slope value of negative 7.8, 7.9 roughly. Do you all have that on your screen? And a y-intercept of 201.2. Okay. Your R value, how come it's negative this time? Because your slope's negative, right? Now, your R value is negative 0.913. So we would consider this to be about how accurate? You have a question? What do you got?
I didn't have a 5, of course.
1, 2, 3, 4, 6. So 5 and 151, you can put them at the bottom. How accurate should we expect this information to be? About 91%, right? It's about 91% of the way to being a straight line. Okay. So here's my question to you. If you came in 15th place, what would your score be? If you came in 15th place. So you can use this line, drag down this line until you find an X value of 15, or using the slope and the y-intercept, create an equation by putting in 15 for the X value. Either way, you should be able to tell me good, to the nearest whole number, right? Because we're talking about how many pins you knock down. You think you have an answer? Yes, it is. Very good. Okay. What do you think? So that slope is a negative 7.
Oh, negative.
Yeah. What's that?
Is that stupid? Like, logical or round up?
Well, yeah, but if it's not greater than a half, don't round up. What?
I just had it. Look, I got it.
Yes, you got it. Good. No.
Gosh, why am I doing?
15th place, not 5th
Oh,
place.
point.
No, how about 1-5, not just 5? 3. Yep. Okay, so how many pins? 83. Did you come up with that? No? What do you got? Huh? So we have to type this equation in right here. So yeah.
4 straight.
Yep. You need that 1 in front of there, right? Because the column has to have a 1 on it. Okay. And then mx1 plus. All right. Yeah. Yeah. There you go. There you go. All right. Okay. So you should have come up though with a pin total of 83. Okay. Now, here's what you got to understand. At some point, because this line continues to go, it's going to lose its accuracy. As I continue to drag along here, eventually it's going to say that the guy in 26th place scored a negative amount of pins, right? Well, that's not possible. But because the line is linear, eventually it gets to a point where it's no longer accurate. So keep that under consideration. All right. Remember, when we start to make predictions outside of this set of values, that's known as extrapolation or extrapolation, however you want to pronounce that. when we predict outside of here. So anything past what we have going in that direction. If it's inside those, it's called, do you remember from yesterday? Interpolation. Which one's more accurate? Inter, because it's on the inside. Okay? All right. So that's where we're going to stop. We're going to start kind of looking at your homework so you guys kind of have an idea of what's going on there. All right. You only have 5 questions tonight, and we're going to start them right now.